This video is going to show how to create accurate AND gate and NAND gate SPICE models in OrCAD PSpice. Open the provided design in OrCAD PSpice 23.1. Select Place, PSpice Part, Modeling Application from the menu. In the Modeling application, expand Digital, Gates. Select AND NAND from the list. In the resulting options window, ensure that the number of inputs is set to 2, the number of outputs is set to Q, and the number of inverted inputs is set to 0. Set the propagation delay to 7.9 nanoseconds, the threshold to 1.4 volts, the hysteresis width to 1.2, the output resistance to 1 milliohm, the input resistance to 10 gigaohms, and the maximum high voltage to 5 volts. Click Place. Click to place the AND gate in the schematic. Select the voltage level marker button from the toolbar. Click to place a probe at the output of the gate. Right-click and select End Mode. Select PSpice, Run from the menu. View the results. The two clock signals generate an irregular waveform at the output of the AND gate. Back in the schematic, select the AND gate and press Delete on the keyboard. Select Digital, Gates, and NAND from the modeling application. Set the number of outputs to Q bar to invert the output. Set the propagation delay to 9.7 nanoseconds, the threshold to 1.25 volts, the hysteresis width to 0.75, the output resistance to 1 milliohm, the input resistance to 10 gigaohms, and the maximum high voltage to 5 volts. Click Place. Click to place the NAND gate in the schematic. Select PSpice, Run from the menu. View the results. The output is inverted. Quickly create the required AND and NAND gate SPICE models and simulate accurate digital circuit behavior with the PSpice modeling application in OrCAD PSpice. For more tutorials, visit us at resources.ema-eda.com, and don't forget to like and subscribe to our YouTube channel.